Hi, this is Hadrian Da Vinci, and today I'm going to show you guys how to set up your own agent. And we'll discuss this in terms of why use an agent, how it works, download an LLM that we can use to power our agent, and then we're going to run Llama CPP via Docker. We're going to create our own Conda environment that we'll use to run our agent code. And then once we do that, we'll discuss some findings. So first and foremost, why use an agent? So an agent is useful because we can use it to automate tedious tasks. So let's say that you have a task that involves you clicking a button at some given interval. This is something which is highly automatable, and this is something that works really well with an agent. Another reason why we may want to use an agent is because it allows us to essentially get output that is way more efficient than having the LLM memorize all possible outputs. So another reason why we may want to use agents is because agents can be infinitely patient. And this is related to the first point. So say you have a task which is really tedious and you make a mistake. That's okay. You can reprogram your agent and then try again. So how does an agent work? Essentially, your agent works by parsing the input that you're passing to the LLM and then determining two things. The first thing that is determined is the function to run. Now, this may also be called a tool. You'll hear that being used a lot. So a tool is the same thing as a function to run. And then the second thing that is determined from the input is, or I should say, are the arguments to run. So say that you have a certain function and this function has, variables or arguments. You can actually determine that by parsing the input. Now, once you have the function and then the arguments, the next step is to run the function and then return the output to the user. So that's essentially how an agent works. It's just parsing the input and then doing something with that input. So next, I'm going to show you guys which model I used. The one that I thought worked really well was Hermes 2 Pro Mistral. And this has various types. I think the smallest one might be like 2.7 gigabytes, and the largest one may be like 8. It might be more than 8, but the one that I ended up using was 4.4 gigabytes. The reason why I use this one is because when I tried using one that was smaller, it just wouldn't work. It was not doing a good job parsing the input, and then the functions that it was pulling up were just wrong, right? So I think when it comes to working with agents, you do want to use, an LLM which is robust enough to get the job done. So yeah, the smallest one, I did try this, and it kind of worked. And then try this one and this one, but the one that I thought was like bare bones that actually did what I wanted was the one that is 4.4 gigabytes, or maybe 4.14. All right, so I actually downloaded this already, and I stored it here in my. Let me make this bigger so you guys can see. I stored this here in my models folder, and what I'm doing here is I have a whole bunch of different projects that I ran, and all my projects use the same model. So I kind of keep the models folder outside of those projects, and then I refer to the models folder in the parent directory. And I'll show you how that works in the next step. All right, so once you have your model downloaded, and this may take maybe 5 minutes, it depends on the connection that you have. The next step is to run Llama CPP via Docker. And as I said before, Docker just works extremely well when running this. I'm referencing the parent directory. I'm referencing my current directory, and then I'm referencing the parent directory of that. The reason why I do that is because of the way that I have it set up here. And you guys may have this differently. I just find this as a really convenient way of setting up my file system. So yeah, that's what I have here. So yeah, that's what's running. So what it's doing is it's mounting my models folder within the Docker container. Again, port 8000 of my Docker container is going to be connected to port 8000 of my host. And this is also really important too. When you're working with agents, you have to enable Jinja, right? And the reason why is because it needs to be able to parse for certain functions. And if you don't have Jinja, I think it just doesn't work with tools. And then in this situation, within the container, because we mounted the models outside the container to models inside the container, we can simply reference our Hermes 2 Pro Mistral LLM. And then here we're running this at port 8000. And as you know, port 8000 is connected to port 8000 side. And this is just localhost. I have my API key. And then I just chose my temperature is 0, which means that it's not going to be random. We should have it be deterministic, meaning that if I ran the same code, I should get the same output, ideally. And then C, I just chose 888 because it's a very lucky number. Okay, so this is my command. I'm going to copy this and then paste this into my terminal here. Okay, I see. So, you know what? I made a mistake. Let me change this. I need to make this into lowercase because this is case sensitive. And then PWD, I need to make this lowercase as well. And then let's try that again. Alrighty, it's working. So now we have it up and running. It's available at port 8000. And before I forget, let me change this because if I don't, I will definitely make that mistake again. All right, so let me navigate to that and make sure it works. Okay, let me just do a quick test and say, hello, LLM. And it's complaining about my API key. Okay, my API key is Apple. That's what I put here. So I need to put API key into the settings here and save. And let's do a test. All right, so it looks like it's working. Perfect. Good. So now that we have this step completed, let's go to the next one. All right, so the next step is to create our Conda environment. So I actually created this environment already. I don't need to do it again, but what I will do is I'm going to activate my Conda environment. So I'm going to go back to my terminal. I'm going to open up a new tab here, and I will do Conda activate LM or ML. Good. So the next step is to code. Before I do, let me install my requirements. And you guys might be asking, why am I installing this? So the reason why I'm installing OpenAI is because OpenAI created a standard that all other organizations have abided with. And essentially, it allows us to communicate to the LLM via an API. So I want to make sure that I have that installed. And it looks like I already have that installed, so that's good. So we have two codes that we're going to run. I want to show you guys a really simple bot. This is really simple. And then I'm going to show you guys a bot that's mediocre. So it's just a little bit more complex. And I think in you guys seeing this, you get a really good idea of how agents work. So I'm going to copy this and then place this into a file here. Let me just zoom in a little bit so you guys can see it. And I will clear this. All right, so I'll do nano, and we want to call this addition agent. And let me give you guys a background. So the first bot we're making is a bot. I call it bot. You can call it agent bot. The first agent that we're making is going to do addition. So we're going to pass it two arguments. We're going to pass it A and B, and then it's going to give us the result. And then the second one that we're doing is going to be a to-do list agent, which is a little bit more complex. All right, so I'm going to name this one addition agent, addition agent.py, and I'm going to place the code. I'm going to paste the code here and save. All right, you know what? Let me open this up in Genie Edit because it's going to be a lot easier for me to show you guys what that looks like. Okay, so here we are in Genie Edit. This is what we just made. So here we are importing OpenAI, and yeah, we're just importing some other things that we're using. You know what? I realized that I won't be needing SQLite. Let me get rid of that. That's for the other agent. And then here we have our base URL. Check this out. You see how we have 0.0.0.0 port 8000. That is actually the same thing as here. If I were to change this to 0.0.0, 0, it will bring me to the same place. And then here, this is the model name. So the model name actually doesn't matter. You may notice that this model name is not what we had written before. We had Hermes 2. This is just a placeholder. And then here we have our API key. So this part of the code is creating a client, and this client is using the base URL that we have here and the API key. All right, so um, this is something that I created. I created this function registry because I wanted a simpler way to register this function. Now, because this agent does only one thing, which is to do addition, I only have one function, and this function is called add functions. It takes A and B, and then it will return the sum of A and B. Now, you may notice here I have a debug message, and the reason why I put this here is because I wanted to see an output whenever the LLM was calling this function. I wanted to make it obvious to me that this function is being called. All right. Um, this is a placeholder. I don't need this. When I was doing some experiments, it appeared that I needed a placeholder function, at least for the LLMs that had that were smaller, that were less than 4.4 or 4.14 gigabytes. I needed a placeholder because sometimes the LLM would actually not find a function, and then it would try to run nothing, and then that caused some issues. So I just wanted to have a placeholder. But as I mentioned, because we're using one that's larger, I will not be needed the placeholder. Next, we have tools, and you guys might be wondering, okay, what's this about? So tools is essentially a description of the function and its arguments. And this is something that's needed by the LLM because if you guys recall, the LLM is going to, at least a wrapper code, is going to run the function, and it needs to know what the function name is. It needs to know what the parameters of that functions are. So that way, when it's parsing the input, it will be able to pluck out A and to pluck out B from the input, right? So that's all this is saying. And then we have a function that we've written here called call LLM. And this takes a query, which is a string. It takes a system role. The system role can be none. It could be nothing. And then what it will do is it's going to have the LLM call this, right? So you see here, if the system role exists, it's going to use the system role. So the first message is just a system role. If the system role does not exist, then there's no message. We're going to have an empty list. Now, what it will do is the query that the user has typed, that will be the second message, given that you have a system role. And that's when we have role user, and then the content is a query. Then after that, we're going to call the LLM, and do note that this is using the API that we have. This is actually using OpenAI's API to communicate with the LLM. Here we're passing the model name, we're passing messages, we're passing the tools, and do note here that we're passing stream faults. The reason why we're passing stream faults is because with the current version of Llama CPP, I'm not able to run agents when streaming is true. Now, there's another version that is coming out that does have that, but this version is not the one that I'm using here. And then what it will do is it's going to extract the message. It's going to extract the result. Well, given that it's calling a tool, right? If the LLM says, hey, the tool that's being called is called add numbers, then it's going to run add numbers with the argument A. So whatever the LLM has determined what A is, and whatever the LLM has determined what B is, it's going to run add numbers with that. Then it's going to print the result, right? So that's essentially how it works. So now that you guys have seen how this works, I have some code which is not in a function, right? It's just simply like setting things up. So we have the system role. It says you are a calculator assistant that only does the addition of two numbers, or the addition of numbers. And then while true, it's going to ask the user, hey, enter your addition related question. And if you want to exit, type Q to exit. Now, if you do type Q, it's going to break and then exit that while loop and in the program. Anything else that you type, it's going to put that into our LLM. It's going to call that. And notice how here it's calling the system role, and it's always using the same system role, right? And I put print here because I wanted to have a new line, and then I'm printing the result. And that's essentially how it works. So now that we see this working, let's try this. Let's spin this up and see how it works. So I'm going to try this first. So here we are at running the agent. So what I'm going to do here, guys, is I'm going to run this agent first, and then afterwards, I'm going to go back to our more complex, slightly more complex agent, which is for a to-do list, and then run that and then see how that works. All right, so let's go back to run agent. So what I've done here is I actually prepared some queries because I thought these queries that I have were pretty interesting, and I wanted you guys to see what would happen. So let me do ls. So we have this. I'll do Python addition agent.py. Okay, so now it's asking me to enter your addition related question. And what I'm going to do here is I'm going to ask the LLM, what is your purpose? So you may notice that this is not actually an addition question. It's just me trying to see how the LLM is going to process this information. Now do keep in mind that this machine that I'm running on right now, I think it has 16 gigabytes of RAM. And this is not VRAM. This is not GPU RAM. This is just like regular RAM. So when I ask a question, it may take a little bit longer to give a response. It takes maybe like 5 seconds. So bam, as you see here, we have our response. And it says, my purpose is to add numbers as requested by the user. Great. So I wanted to see what it would say, and this is good. This is good. So the LLM realized that, hey, this is not an addition question. There's no A, there's no B, and it actually answered the question. So that's really remarkable. All right, let me ask that question differently. I'm going to ask it, what are you? While that's processing, I'm going to copy the next question. So let's go back. All right, so what are you? So the LLM answered and said, I am a calculator assistant that can only add numbers. Okay, good. Now, this next question that I'm asking is not even a question. This is technically, this is just kind of gibberish. And I wanted to ask you something that was ridiculous because I wanted to see how the agent would respond, right? So again, notice that we're not asking it anything that's like, hey, what's 2 plus 3? We're not asking that. We're just asking, we're actually entering something which is nonsensical, and we're looking at the result. So when I do that, it says this input is not valid. It's not a valid number. Addition request. Please provide 2 numbers to add. So this is really great. I'm really glad that our agent was able to realize that this is not a query that you can pull out an A and a B. All right, so now let's ask it, what is 2 plus 9? See what it says. So for this one, we would expect it to say 11. All right, great. So it says 11 as the answer. That's great. And notice that it says running add numbers function with A as 2 and B as 9. And this is great. This is exactly what we expected. If you guys recall, when we're running this function, when the agent is running this function, we have a debug message. And this debug message is just letting us know that, hey, the agent is in fact running the function that we have programmed, right? And this is great. Okay, so let's try that again. We're going to try we're not going to ask what is, we're just going to enter 2 plus 9. It's 2 plus 9. So again, we would expect the answer to be 11, and we would expect to have the same run add numbers function and all that. Perfect, good. So as you see here, we did not ask it what is, but the LLM agent was able to parse our input and then pull out the 2 and then pull out the 9. And then it has the result as 11, and it has our debug message here. So this is really great. All right, next, we're going to ask it the same question, but we're going to throw a twist. We're going to ask it 2 plus 9, but as words, not numbers. So let's see if our agent is able to know that this 2 is equivalent to the number 2, and the 9 is equivalent to 9. And it looks like it is. This is perfect. It gives us the result that we expect, and it has our debug message here. Great. All right. Um, so someone had asked me to run this one, and I'm going to run this. So let's try to mess up the agent. So we're going to do what is 2 plus 9 plus 8. So notice here we're asking it the addition of 3 numbers, and the agent is not programmed for this. So let's see what happens. Ah, okay. So it looks like what the agent did is that it took the first 2 and then ignored the last number, right? So it just only sees the 2 and the 9, and it does not see the 8. All right, fair enough. So I'm going to ask it something which is nonsensical. So I'm going to ask it just AAA and see what it says. I would expect it to say, hey, this is not valid. This is not even something that you can add. But you know what? No, I did not see that. So what's happening here is that the agent's actually adding this. So it's parsing this AAAAA, many A's, and it's pulling out a 1 for A and a 1 for B, right? So this is not exactly correct. Now, one of the questions that you guys would ask me is, okay, how do we get around this? My response would be use an LLM that is larger. So right now we're using 4.4 gigabytes or 4.14 gigabytes, right? I think if we use a larger LLM, it's going to be much better at parsing this. In fact, I tried this with an LLM that was 12 gigabytes, and it was able to, in fact, realize that this is nonsensical, and it said, hey, this input's not valid. All right, so I'm not going to run through all of these, but I will do 2 more. Um, I'll do 2 plus 5. Actually, let me do 1 more because I think you guys kind of see the gist. You kind of see how this works. So we'll do 1 more. We'll do 2 plus 5. So 2 plus, so we have the number 2 plus 5 as a word. So let's see if it's able to parse this and give us the result. We should expect a 7. Perfect. So it can tell that this 2 is the number 2 and this 5 is the number 5. And it does, in fact, give us 7. So this is great. Perfect. So again, I wanted to show you guys a simple agent that essentially is searching for 2 inputs, A and B, and then is looking to run it through one function. So next, we're going to do a more complex agent.